Okay, let's take a look at how I would do these problems, walking ourselves through the practice test. So I'm going to do these without looking at the multiple choice options so you can get a sense of what the problems might look like on the actual test. So rewrite the quadratic equation in standard form by completing the square. Y equals x squared minus 8x 20 over. Half of 8 is 4, so we're going to add 4 squared, 16. We also need to subtract 16. So y equals x minus 4 squared plus 4. Find the vertex of the parabola associated with this. So the vertex is at 47, 18 from H and K. All right, find the general form. So we're going to say y equals a h squared plus k. And so we have a y number, 30.2, equals a, which we will solve for. We have an x number, 2, minus negative 5, so 2 plus 5 squared, plus your k, 5.7. So let's subtract 5.7 from both sides. And we get 24 point, what do we have here? 24.5 equals 2 plus 5 is 7. 7 squared is 49a. And divide both sides by 49. And you end up with 0.5 for a. All right, so I'm probably going to, on the test, ask you for the standard or the vertex form, which we can now write. We could write y equals 0.5 x plus 5 squared plus 5.7. All right, but in general form, what we could do is we could FOIL this out, y equals 0.5, and so we would have x squared plus 10x 25 plus 5.7, and so y equals 0.5 x squared plus 5x. Half of 25 is 12.5, plus 5.7 would be 18.2. All right, graph this. So remember that to graph the quadratic function, we need to first find the vertex. So we're going to have negative b over 2a for our h, which is the x at the vertex. And so that's going to be negative 2 over 2 times negative half. That's going to be 2 over negative 1, which is 2. And if we plug this back in for our k, we will get negative 1/2 of negative 2 squared. Is 2 times negative 2. And so that is 4. Half of that, so negative 2 plus 4, which is 2. We're going to go to negative 2 comma 2. And let's plug in our y-intercept. Our y-intercept here is 0. Make sure to label all your points, 0, 0, negative 2, 2. And point of symmetry would be negative 4, 0. Connect your dots. Make sure to remember to label your axis of symmetry, negative 2. I match the quadratic function to an equation in standard form. We could do this without matching it. We could say here that our equation is y equals a, x minus 2 squared plus 2, because the vertex here is at 2, 2. And so then we just need to plug in and find for a. The nice thing here is that it does cross 0, 0, so we can say 0 equals a plus 0 minus 2 squared plus 2. And so we're going to have 0 equals 4a plus 2. So a be negative 1/2, negative 2 divided by 4. And so we can write y equals negative 1/2 x minus 2 squared plus 2. Okay, let's find all the zeros. We have 0 with a multiplicity of 3 from this one. We have negative 9 with a multiplicity of 1. And we have 8 with a multiplicity of 1. All right, let's find our polynomial. Y equals minus 5, x minus 4 plus squared. Find all the real zeros. So the real zeros here today. Find all the zeros, yes. All right, so find all the real zeros here. So same thing, we're going to have 0 multiplicity 6. We're going to have 5 multiplicity of 6. We're going to have 18 multiplicity, sorry, negative 18 multiplicity of 5. And we're going to have 10 multiplicity of 1. And we will see here, oh, no, that's good. All right, on this one, we're going to have 2, the multiplicity of 2, which means it touches. We're going to have negative 5 with the multiplicity of 1, which means it crosses. Our y-intercept is negative 2 squared times 5 with a negative out front. So this is negative 4 times 5, which is negative 20. And our end behavior, this is a negative x cubed graph. Our end behavior is going to be like this, start high, finish low. Let's put it all together here. Positive 2, we're going to touch. Negative 5, we're going to cross. Negative 20, we're going to cross. We're going to start high. We're going to finish low. And so we're going to do something like this. Just touching right there. All right, let's do our long division here. So x plus 7 goes into x squared plus 9x plus 21. No need for placeholders, but be careful if there are placeholders. All right, first step, x squared divided by x. Divide your leading coefficients. That's just x. And then we're going to distribute to the outside, x plus 7. We'll get x squared plus 7x. Track straight down, we're going to get 2x. Bring down the 21 and start over. 2x over x is 2. Distribute that to x plus 7. It's 2x plus 14. Back straight down, and we end up with 7. We'll say plus 7 over x plus 7. All right, synthetic division, we're going to put 7 on the outside, and we'll get 3, a negative 27, a 39, a 25, and a negative 28. Bring it down. So we have 3, 21, negative 6, negative 42, negative 3, negative 21, and so this is negative 4, and so, so positive 4, and so positive 28, which is 0. So it comes out clean, and this gives us, this used to be x to the 4th. We're going to have 3x cubed minus 6x squared minus 3x plus 4. All right, 12. I would do this with synthetic because it is x to the 1st, so you're allowed to do it with synthetic. So we have 4, 2, negative 5, 20, and 12. Got here. 8, so negative 6. 12, so 7. Negative 14, so 6. And negative 12 comes out evenly. So we end up with 4x cubed minus 6x squared plus 7x. 13, this is a division problem, so we can say 20x to the 4th minus 42x cubed is 8x squared, 15x 2, 4x minus 2. Right, 20 over 4 is 5x cubed. Get 20x to the 4th, and then minus 10x cubed. So we get 32, negative 32x cubed, minus 8x squared, plus 6x minus 2. Start over, 32 over 4 is minus 8x squared. And so we'll have minus, plus 16x squared. So back down, and we get negative 24 x squared, 6x minus 2. And so that's going to get us a minus 6x. So plus 12. And when we subtract here, we get 4x. 4x minus 2, that comes out as plus 1. All right. Oh, I left this up there. Didn't need that, but we're going to do this synthetically. Plug in 2, the 1, 5, negative 2, and 6. 1 and 2 and 7 and 14 and 12 and 24 and 30. So the answer is 30. F of 2 equals 30. All right, determine whether the number is a 0. If it is, find the other ones. Do it synthetically. 1, 2, negative 15 and 10. 1 and 1 and 3 and 3 and negative 10 and negative 10 and 0. It does work out. So then we're left with x squared plus 3x minus 10. That factors to x plus 5 and x minus 2. So your zeros are x equals 1 from here, 2 from here, and negative 5 from here. 16, 6 is a 0, so let's plug it in. 1, negative 10, 27, negative 18. 1 and 6 and negative 4 and negative 24 and 3 and 18 and 0. So we have x squared 4x plus 3. We have x minus 3 and x minus 1. Your other zeros are x equals 3 and 1. Given that negative 4 is a 0, let's determine all the other zeros. So we'll put negative 4 in there. 1 and 13 and 54 and 72. 1, negative 4, 9, negative 36. And so what do we have here? 18 and 18 times negative 4 is negative 72. That works out. So we have x squared, 9x plus 18. Okay, the question here is, can we multiply to 18 and add to 9? We can. 6 and 3 is x plus 6 and x plus 3. So your remaining zeros are negative 6 and negative 3. All right, given a 0, the polynomial will determine all the other ones, and it looks like I've gotten rid of that. So pause for a second. Come back. Okay, there we go. All right, so on this one, we're going to go into our graphing calculator and see what we get. Let's see. Pause this again and graph it. All right, so I graphed it, and it looks like this. So it looks like it crosses at negative 1 and positive 9. So negative 1. We'll go synthetic. 1, negative 16, 72, negative 64, negative 153. And off we go. 1, negative 1, negative 17, 17, 99. Is that right? Yeah. Nope, 89. Negative 89, and that is negative 153. We get 150. So that comes out, and then we also thought it crossed at 9. We get 1 and 9 and negative 8 and negative 72. And what do we have here? 17, and 17 times 9 is 153. We're in business. All right, so factored form, this is going to be x plus 1, x minus 9, x squared minus 8x plus 17. And we are done. We have factored it. All right, same thing on this one. Let me pause and graph it. All right, looks like negative 4 and positive 6 are our answers. So here we go, negative 4, 1, negative 2, 1, negative 50, and negative 600. 1, negative 4, negative 6, 24, 25, negative 100, negative 150, positive 600. Works out. Let's check the 6. 1 and 6 and 0 and 0 and 25, 150. It checks out. So we've got x plus 4, x minus 6, x squared plus 25. 20. All right, same thing on this one. Let's pause and graph it. All right, looks like 4 is our daisy. Let's plug this in. 4, 1, negative 14, 74, and 136. 1, 4, negative 10, negative 40, 34, and that's 136. So that is correct. And so this does not factor. We're going to have x minus 4, and we're going to have x squared minus 10x, 34. All right, 21, we're going to have x times x minus 5 plus 3i, and x minus 5 minus 3i. Do the box method, x minus 5 minus 3i, x minus 5 plus 3i, squared, negative 5x, negative 5x, 25, cancel, 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 and we're going to have negative 9i squared, so that's positive 9. So we're going to have x squared minus 10x plus 25 plus 9 is plus 34. And there's an x on the outside. Don't forget about that one. X cubed, 10x squared, plus 34x. 22, same deal. X minus 2. X minus 2 plus 7i. X minus 2 minus 7i. So we've got x minus 2 minus 7i. And x minus 2 plus 7i. X squared, negative 4, negative 2x, negative 2x, positive 4, cancel, 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 and this will be negative 49i squared, so positive 49. So we get x squared minus 4x plus 53, and then x minus 2 on the side. So we're going to get x cubed, negative 4x squared, 53x, negative 2x squared, 8x, and negative 106. And so I'll have x cubed minus 6x squared plus 61x minus 106. All right, 23, the domain of this, factor the denominator, x plus 8 and x plus 10. Nothing cancels with the top, so we're going to say x does not equal negative 8 or negative 10. Find the domain of this, all real numbers, because x squared plus 1 does not factor. There's a plus in there. All right, vertical asymptotes, horizontal asymptotes. The vertical asymptote, you're going to say 9x plus 4 does not equal 0. Or sorry, asymptote equals 0. So we're going to say x equals negative 4 over 9. And your horizontal asymptotes, x to the first, they match. So we're just going to say y equals 8 over 9. 26, got to factor the top and the bottom. The top's not going to factor. I won't give you, well, I'll just tell you it doesn't factor. On the test, it'll be either an x squared and easy to factor, or it won't factor at all. I'll just give you a little hint there, but let's factor the denominator. This is 8 and 3. All right, so our vertical asymptotes are x equals negative 8 and x equals negative 3. And your horizontal asymptote is at 9 divided by 1, y equals 9. Okay, match the rational function to the graph. So it won't say something like this. We'll say something like graph it. So the key takeaways on this are we have a vertical asymptote at x equals -2 and x equals 1. We're to graph this, we go to -2, go to 1, and then this is on top x squared, and on the bottom x squared. So we'll have a horizontal asymptote of y equals 1. And I believe it looked like this. We'll have to check the graphing calculator. Let's see, it goes up like that, and then like that. Okay. All right, last one. Something like this will not be on the test because of multiple choice. It'll be something like graph this, but maybe extra credit. So match the graph to the rational function. This is x equals 3, and this is x equals -3. So we know the denominator has an x minus 3 and an x plus 3 in it. No, 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 it's got to be a. All right, same deal here. We have vertical asymptote at x equals 1 and at x equals -1. So our denominator must be x squared minus 1, must be c. All right, there you go. Hope that helps. Good luck on the test.